Hi everyone, this is the basic geometry review. So here we go. For number one, remember when you have angles across from each other like that, those are called vertical angles. So I would know that this is 29 degrees, but these two angles here that create a line from this shared vertex add to 180 degrees, they're supplementary, so we get 151 degrees. In question 2, they have a sum of 90 because remember that means 90 degrees. So this is as simple as 90 minus 52, and that's where the 38 comes from. In question 3 and 4, we're still working on that concept. So again, I have vertical angles there. So this is as easy as 72 degrees. Over here, this is 90, which means that the two over here also are 90 because that's all three of those. 1, 2, 3, the 90, angle B, and 64, they add to 180. So really you can just do 90 minus 64 to end up with the 26 degrees, or you could have done 64 plus 90 plus x equals 180, and that would have gotten you the same thing. Same concept here. Again, that has to be 90 because that is. So 90 minus 38 is going to be 52 degrees. This is again a linear pair because I have that shared vertex making the straight line. So 180 minus 35 is 145 degrees. Same concept, just now with algebra. So when I'm looking for the value of x, but I have something like this set up, I still know that they add to 180, but I have to do it algebraically. So 73 plus 3x plus 2 equals 180. From there, I'll work through my algebra. Subtract 75 from both sides and divide by 3, and that is where I get 35 for my value of x. Over here, it's the same concept, but they add to 90. So 47 plus 1 plus 6x. If that were a minus, just a reminder, I would put that in parentheses. Just anytime you're doing algebra, that is a good thing to do. So those add to 90. So I have 48 plus 6x equals 90. I go through and subtract 48 from both sides, and I get 42. I divide, and I end up with 7 for that question. So that's the first page. On the second page, number 9, I have these two adding to 90, so I would add them. I'm just going to add them while I go. So 4x and 4x is 8x, 1 and 1 makes 2, so that equals 90. I have 8x equals 88, so x equals 11. And again, here, those are vertical angles, so this time I set them equal based on that circumstance. And I get 42 equals 2x, so x is 21. So pretty much it's all algebra. You just have to know when to solve for what. Okay, for distance formula, I'm just going to grab a sheet of graph paper really quick. I want to remind you that you can always graph these. So for the first example, hopefully this is big enough. If not, it's my own fault. I'm going to flip it upside down because it's not big enough. Okay, I have negative 5, 8. So negative 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. So there's my first point. And my second point is at negative 2, 8. So negative 2, but also 8. So this is the segment they're asking about. This is very clearly a distance of 3. So that's how I can get it by graphing. Okay. You can also use the distance formula, which I'll show in an example in a second. But you always can graph to find it or use distance formula. In the second example, so we have 8, negative 2, and negative 2, 6. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, negative 2, and then negative 2, 1, 2, 3, 4, 5, 6. Okay, so those are my two coordinates. I would be using a straight edge. I'm just kind of estimating right now. Any segment you draw, this is different than the other one because this is diagonal. But anytime you do this, you can make a right triangle. So even if you don't memorize your distance formula, you don't have to, because if you graph it and then make this right triangle, 1, 2, 3, 4, 5, 6, 7, 8 is this side. This side is 10 if I count. I can use the Pythagorean theorem for it. Remember, the hypotenuse, in this case the length that we're looking for, is always c. So 8 squared plus 10 squared equals c squared. So this is 64 plus 100 equals c squared, which is 164 equals c squared. So it's the square root of 164 equals c. For the simplest radical form, remember you don't have to do that. I won't be grading you on that part, but I will show you how to do it just as a reminder. I call it a factor tree. That's what it's called. It's not just me that calls it that. So we break it down into 2. So that'd be 2 and 82, which would be 2 and 41. 41 can't go into that. Can 3 go into that? I don't think so. I think honestly I'm done there. So I see that I have these 2's. So what that means is that it's technically the square root of 4 times 41. So the square root of 4 is 2, so that comes out, and then the 41 is left under there. We reviewed that at the beginning of the year, but honestly, I'm just looking for that right now. Second option to solve for this is the distance formula, which means you'd have to memorize it. Here is your distance formula. So it's the change in y squared plus the change in x squared, which again, this just pictorially, this is the change in y, this is the change in x, so it's the Pythagorean theorem, and then it's the square root of that, which you have to do at the end. And then you would substitute the values in. So you would substitute 6 minus negative 2, so that'd be 6 plus 2, so we get 8. And then x minus x, negative 2 minus 8 is negative 10. The negative doesn't matter because it's going to get squared, so we're still going to end up with 64 plus 100, giving us the square root of 164. So as you can see, whether you do it graphically or with the formula, you're going to end up with the right answer. I'm going to do these next two with the formula, but again, please graph and use the Pythagorean theorem if you don't want to memorize your formula. So using my formula, I would have negative 3 minus negative 2, making it a plus negative 1 minus negative 8, again making that a plus. So here I have negative 3 plus 2 is negative 1, square root is 1. You can type that all into your calculator as well. As a radical is how I'm going to always put my answer unless it tells me to round. So negative 3 is 1 squared plus, so I'm just going to put that over here to the side, plus negative 1 plus 8 is 7 squared. 1 plus 49 is the square root of 50. That would be 5 radical 2 for those of you that simplified. In number 14, again, I'm going to set up my formula. Negative 6 minus negative 8, so plus, squared. Negative 1 minus negative 5, so plus again, squared. This is 2 squared plus, this is 4 squared. 2 squared is 4, 4 squared is 16, so that's the square root of 20. And that would reduce to 2 radical 5 for those of you reducing. Okay, midpoint. Again, use a graph. Okay, so I'm going to do 15 with the formula. I'll do 2 with the graph just because I'm using giant graph paper right now and I want something smaller. The formula for midpoint is add your x's, so 2 plus negative 10 divide by 2. Add your y's, so 10 plus 2 divide by 2. Add your x's, add your y's, divide both by 2. 2 plus negative 10 is negative 8. Negative 8 divided by 2 is negative 4. 10 plus 2 is 5, or excuse me, 10 plus 2 is 12. I started dividing in my head. 12 divided by 2 is 6. So negative 4, 6 comes from that one. In number 17, I'm going to do it graphically, just to remind you that you can. So I have 2, negative 6, 1, 2, oh, let me move it up here. So 2, negative 1, 2, 3, 4, 5, 6, and 0, negative 2, 0, negative 2. Again, if you were to draw your right triangle, just go halfway for each. So this is 2, so here's halfway is 1. Here's 2, so here's halfway. Right there, had I used the straight edge, it would have hit exactly. So the answer is 1, negative 4. So 1, negative 4. So I'll just do the other two with the formula. Negative 4 plus 1 is negative 3 over 2, comma 10 plus 10 is 20 over 2. So I would just leave the negative 3 halves as such. If you want to write it as negative 1.5, you can, comma 10. 5 and 9 is 14 over 2. 4 plus 10 is 14 over 2. So this is 7, comma 7. Notice everything is in parentheses because it is in fact a midpoint. All right, finding the measure of the angle given. When it's like this, you can go the long way, but what I'm trying to do in all 4 of these is remind you of the fact that the 2 remote interior angles add up to equal the exterior angle. So again, that means 92 equals x, what I'm looking for, plus 26. Sorry if the focus went in and out on that. So really I'm just subtracting 92 and 26, and that is where I get the 66 degrees from. Over here, same thing. 95 equals those 2 added up, so 95 minus the 50 is 45. That easy. Down here is where that can come into play a little bit more, especially in that one. Trying to do the algebra for this is just messy, but if you remember that this plus this, so 4x and 7x is 11x, 2 and 1 makes 3. Those 2 add up to equal the exterior angle. That's all you need to remember. So 11x equals 77, therefore x equals 7, and I check that that's what I'm asked for, so x is equals 7. Really messy, sorry. Here, same thing. 6 plus 24x is my exterior angle. That equals the sum of the remote interior angles, which would be 13x plus 72, because I add my like terms. From here, I would subtract 13x from this side and end up with 11x. I would subtract 6 from the other side and end up with 66, so I get x equals 6 from that. And again, I already checked that that's what I was looking for. On the back, number 23, this is pretty simple. 3 angles in a triangle. 9x plus 135 equals 180, right? We add them all up and set them equal to 180. I subtract my 135, I divide by 9, and I end up with 5 for x, and then when I substitute that back in, 4 times 5 is 20, and that's how I get 20 for my final answer. Moving down here, it's a bunch of the stuff all together. So I see that I have vertical angles here. So if I start on this side, I have 105 plus 20 is 125. And I'm going to subtract that from 180, giving me 55. If that's 55 degrees, so is that because of the vertical angles. And now I have another triangle, switching colors. Another triangle here. Those 3 add to 180. So this would be 130, making my final answer 50 degrees because they have to add up to 180. And again, that was 180 minus 130. That got me the 50 degrees for my final answer. Over here on 25, again, I'm hoping you see this first triangle. That's 104, giving me 76 degrees here. So these 2 added to 104, and I subtracted from 180 to get the 76. Now we have, that's a 6. Now we have these 3 angles all sharing a vertex. Those all add to 180. So 76 and 71 is 147. When I subtract that from 180, I end up with 23. So that's where I get 23 from there. Now I have my final triangle, so that's 45. 180 minus 45 gives me my 125 degrees. Again, I had to subtract from 180 for that. Okay. Moving down here, I have a lot of relationships happening. I have an isosceles triangle here because of those markings. I have an isosceles triangle here because of those markings. What that means is that this angle and this angle are equal, and that this angle and this angle are equal. Okay, they might be different equals, so I'll do a double arc on those. The reason I know that is because where the 2 equal legs meet is not the equal one. That's called the vertex angle or the apex angle. These 2 are the base angles, and those are the ones that are equal. So now I focus my attention here. I have a linear pair. So if this is 114, I can do 180 minus 114 to give me that. And I believe that would be 66 degrees. I'm just going to double check that with my calculator real quick because I don't want to mess this whole problem up because I'm kind of confident. Yep, no, I'm right. All right, so 66 degrees. Now, if you're thinking vertical angles at all, you have to be really careful here. The reason it's not vertical angles is because I don't have 2 straight lines crossing, so we can't do vertical angles. So I'm just going to follow this. So 66 degrees goes here because they're equal. 66 and 66 is going to give me 132, and I need to subtract that from 180 to get my final angle right there. So 180 minus 132 is 48. So I get 48. This is a 90-degree angle. 90 minus 48 is 42. And now finally, I'm at X. I have a linear pair right there. So 180 minus 42 is how I get my final answer of 138. If you really wanted to, you could have kind of gone the roundabout that way and got in all four of those adding to 360, these two adding to that angle. You could have done that, but I found this way more efficient for where my brain was headed. Over here, I see the 103. I can automatically get this one. Again, the X is not 103 because those aren't vertical angles, because it's not, this is straight, but this is not a straight line, so that's why those are not vertical angles. But I can get this to be 77 degrees because they add to 180. Now, because of this isosceles triangle, I know that this is also 77 degrees, which leads me to knowing that that last angle, because 77 and 77 is 104, I subtract from 180, and I end up with 26 degrees here, which can get me this angle in this purple triangle, because those add to 90. So if I subtract 26 from 90, I end up with 64. And now again, these are base angles, those are congruent. So if I do 180 minus 64, I'm at 116, and I need to cut that evenly between those two, so I divide it by 2, and I end up with 58 degrees on both of those. So that's where 58 degrees comes for that final answer. In 11, you're supposed to realize that these triangles are congruent, angle, side, angle, if you want to think of it that way. So if that's 11, that's 11. Should be easy peasy. Same thing here. If that's 10, that's 10, because those are congruent. I like those ones. They're quick and easy, and, you know, who doesn't like those? Measure of angle 2 is x plus 116. So if I'm here, I see my 72 automatically from there. Again, I'm trying to work my way around to get to this linear pair. So in order to do that, 72 and 72 is 144. When I do 180 minus 144, I'm getting 36 for this vertex angle. These two add to 90. So to get the angle in this pink isosceles triangle, I'm going to do 90 minus 36. And I believe that would be 54. I'm just double checking. Yep, I'm not lying. Okay, that's 54. Now, because of this isosceles triangle, this is also 54. And I'm going to go back to one that we did a little while ago. Do you see my exterior angle here? This plus this equals that. So I can just jump to this being 108 degrees, or I can go the long way and solve for this and go to that. Either way works. You see that I jump back and forth between the two. And then to get x, I'm going to set 108 equal to x plus 116. So for number 30, negative 8 comes from subtracting 116 from both sides and getting x equals negative 8. Okay. Moving over here, it's a very similar scenario. I can get 71 because I have my isosceles triangle there. 71 and 71 is 142. 180 minus 142 is 38. These have to add to 90, so this is 52. Now I'm in a new triangle that is isosceles because these are the isosceles parts. These are both 52. 52 and 52 make 104, or go the long way. Everything here are mid-segments. The reason, excuse me, the reason I know this is a mid-segment is because those are midpoints. Anytime that happens, this is half of the side it's parallel to. So this is simply 18. Here, this is 4. Whenever you see that happen, it's simply half. To solve something like this, I know 2 of these makes one of those. So 2x plus 28, I'm multiplying that by 2, equals x plus 22. So I end up with x equals negative 6, I believe. Excuse me. Yes, I'm right. Same thing here. 2x plus 32, because 2 of these equal one of those, equals x plus 21. So I get x equals negative 11. I was going to say 9. 11 makes more sense. I have a right triangle and I'm missing a side. This is 1000% Pythagorean theorem. Remember, C is the hypotenuse. That's super duper important. So you have to remember where your hypotenuse is. We don't care about opposite and adjacent right now, but we do care about hypotenuse. So again, you can ignore the simplest radical form part of this. I have 14 squared plus x squared equals 16 squared. So when I do that out, 16 squared minus 14 squared, x squared equals 60. You can just, leave your answer as the square root of 60. Here, x is the hypotenuse. So it's simply 6 squared plus 9 squared equals c squared. 6 squared is 36, 9 squared is 81. 36 and 81 add to 117, which is not a perfect square, so I will just leave it as the square root of 117. You must know Pythagorean theorem. Here is a way for me to remind you that if you see something ugly in the Pythagorean theorem, okay, you need to know how to deal with that. Right now it's saying, is it a right triangle? This means to test for Pythagorean theorem. So 13 is my hypotenuse, so that's my c squared. And here, this is how you should be typing this into the calculator. Exactly how I'm writing it right now. Okay. When you type it into the calculator like that, it's gonna all work out. So when I do 169, okay, that side, equals 101, the square root of 101 squared is 101, plus 2 radical 17 squared. When it looks like that, you're going to get 4 times 34. No, that's a lie. 4 times 17 is what I meant to say. Your calculator will do that for you. I was doing it the other way. So you end up with 169 equals 169. Yes, it is a right triangle. If it said explain, you would say it is a right triangle because it satisfies the Pythagorean theorem. That's how that would work. So over here, here is my hypotenuse. So 4 squared is my c squared equals 14, the square root of 14 squared plus the square root of 2 squared. So this is 16 because 4 squared is 16. When you type that in, you get 14 plus 2. So you get 16 equals 16. So it's a yes again. A yes has an S. Here we have angle bisectors. If they're telling you what the measure of angle 1 is, the measure of angle 2, if that's a bisector, is the same. So this is just reminding you that a bisector makes 2 equal halves. So 2x equals 16, x equals 8. That's an 8. Yay. And then for the last one here again, I'm giving you angle 1 and I'm giving you angle HFG, so pay attention there. This time it's different. This time I'm not giving you 2 equal halves. I'm giving you something that when multiplied by 2 equals the whole thing. Okay, so right, this is the same as that, and the whole thing is 10x. So this would be 12x minus 16 equals 10x. Subtract 10x, add 16, you get 2x equals 16, so x equals 8. And that is the basic geometry review for your first mastery quiz. I'm hoping this was helpful if you used it. Have a great day.